Hey guys, welcome back to your own channel. In today's video, we are going to cover visualization with the help of Python. It's crucial topic for any data person, so stay tuned. Before we begin, I would like to give you some glimpse of the videos or topics which we are going to cover. There you go. Your time is super important for us, and that's why I'm giving you chapter links right here, and you will find the same in description box. So if you want to attain specific section of this video, you should go and watch it there. But if you're continuing and watching the full video, I'll be super happy. Also, if you are liking this video, please hit that like button. Please also subscribe our channel and hit that notification icon on. This will motivate us a lot. So without any further ado, let's begin. So I'm here on my Jupyter notebook, and let me initiate the new notebook with Python 3 kernel, and that will open up a new notebook for me. And let's first rename our notebook Python for Beginners Part 5. There you go. Let's first import all our libraries. Let's call import pandas as pd to manipulate data frames. That's also called numpy in case if you want to do some kind of mathematical operations on this data. We're also calling matplotlib, and matplotlib, from within Matplotlib, we are calling pyplot, which acts as kind of a base visualization library for you. And we're also calling Seaborn. Now, Seaborn is very famous library for visualization, and which sits on top of Matplotlib, include all of them. Let's begin calling our data as df is equal to pd read Excel, since I have data in Excel format, and the data today I have is car insurance claim, and once I press enter, the data gets stored under data frame df. And let's first see the data with the top sample. So we should do df.head, and that will give me top sample from the data. So this is top 5 rows I have from the data. I have so many columns with me, around 21 columns. And so I have a different data types of each of the column. And this is, since it's an insurance data set, which includes car, claim amount, urbanicity, occupation, travel time, gender, marital status of claimer, and customer ID for each of the customers. So it's a very comprehensive data set. Before we go and begin plotting different types of graph, our objective out of this session is to understand different types of graph and how do we plot them using Python, and specifically 2 libraries as we specify. That's the purpose of our today's session. Before we go and build some visualization, let's try and understand the data points. So we already seen the head of it. Let's just see what is the size of the data set. So we should do df.shape. As we do that, we know that we have 7,647 data points across 21 columns. So we are a sufficiently large data set to create different type of visualizations, right? Okay, let's begin our first visualization of the day, our first chart of the day. That's histogram. So histogram, as we say, is also referred as a frequency chart, and it's very crucial when you try and understand distribution of any kind of variable in your data. Histogram is mainly used for continuous variable only. So let's begin. One of the variable, let's take income for now, and this is how we plot histogram. We'll call sns.histplot. So you're calling SNS library, Seaborn library, and you're calling histogram plot, which is histplot, and you provide your data. So your data is nothing but data is equal to df, and you're saying your x is now your axis. So you're saying on x-axis, you would like to provide income. Now, you need to ensure that the column name which you put on your axis has to exactly match on your data frame, because Python is case sensitive. So any kind of error will result in column not found or name error or any kind of other error. So please ensure that you put correct column name in all the graphs which you're going to put up. Let's run this cell. Okay, we find a beautiful histogram which is blue in color, and you find different type of frequency for each of the income slab. Now, income slab is continuous variable, and you see all these bars are adjacent to each other. It's kind of touching each other, and that's a peculiarity of histogram. It's not a normal bar chart. Let's customize this chart now and understand what all different keyword arguments that we can put and make our graph more beautiful, or we can alter this graph. So if you want to change the size of the graph, you can do something like this. You can do plt.figure, and you can provide fixed size. Now, when you fix size, that means you are specifying your size of the figure in width versus height. So I'm saying that 6 units of width and 4 units of height. And then I'm saying plt.title, which I wanted to put. So I'm mentioning histogram for income, and that's my title. This will give a nice title to our chart there. I'm also going to specify limit for my axis. So xlim is used to specify the limit of x-axis. Say x-axis will start from 0 and go all the way to 400,000. Similarly, I can also provide y limit for y-axis. So plt.ylim, which will start from 0 and can go all the way to maybe 1000, right? And we can also specify label for x-axis. Right now, label is there, income already. So we can specify x label. Now, x label is nothing but it's income. And similarly, I can also specify y label, which is nothing but count or maybe frequency, right? And once we have it, we can call our graph sns.histplot again, and we are providing data is equal to df, and x input is nothing but my income. Now, if I want to change the color of the graph, I can put color is equal to orange here in inverted comma. This is as a string input we're giving, and we're saying bins is equal to 20. And once we execute this, we're going to get a nice histogram, but with different number of beans. Here we are specifying beans is equal to 20. So what it essentially does, it will take from 0 to all the way maximum value and divide this range into 20 equal bins. And for each of the bean, what is the frequency? Now we see that there are certain frequency which is not being covered under this 1000. So we should increase our y limit. So when we do 2000, we get the correct picture, each of the bin getting correctly captured within the graph. You can change your color. You should visit SNS documentation on Seaborn website to get details about different colors. Right now, if you want to change instead of bins, if you want to specify the bin width, let's say if I want to specify maybe instead of 50,000, if I wanted specific bin size, let's say 40,000 for each of the bin, I can specify the bin widths instead of total number of bin numbers. I can also specify kernel density estimator, which is kind of a point density function which acts as a probability for each of the pins, and you can do that. So let's first copy this thing here and let's just put it here, and name it title as KDE, so kernel density estimator chart. And here everything remains the same except for color. I can change maybe to differentiate slightly. So I'm saying give me an olive color, and also I'm saying bin width. Now bin width, in sense, what is the size of the bin I require? So I want maybe 40,000. That's my bin width I'm expecting. I'm also saying kernel density estimator KDE is equal to true, which will also give me the KDE plot. Now, since my bin size is more and graphs are coming out of the boundary, so I should increase the Y limit, and maybe 3000 should be enough. Once I put 3000, it still requires some kind of more addition. Let's put 3500 to clearly see it. And now this should be okay. We see that each of the bin is nothing but it's a 40,000, and 0 to 40,000, there are 3000 such records, which is there. Cars is there. Then between 40,001 and 80,000, there are another maybe 2,700 records there, and so on. And the little line which you see in dark olive color, which is nothing but it's KDE plot, it's kernel density estimator. It gives you along with the probability, and it's kind of a distribution pattern of your data for income. So this kinds of give you the skewness in the data. If it's highly skewed, whether there is a symmetry or the normal distribution, it gives you all those kind of insights within your data, right? Now, if you wanted to study several groups within the histogram, you can do that. And this is how we do it. Let's say sns.histplot, and within histplot, you can say data is equal to df, and you can give x input, which is nothing but income. And we wanted to study this income against all different type of occupation. You can do that, and we can put hue as occupation. And we can also provide KDE is equal to true to see how the distribution for each of the population appears to be. And as we execute this, going to get a plot which is good, but very complex. Like it's very difficult to read out of this plot for each of the different population in there. And so you know that, okay, there are some curves which having some symmetry, like maybe a blue color, the graph in orange, but it's not clearly visible because there are a lot of overlap between each of the population, so it's difficult to read it. So in such scenarios where you are studying different groups, it's always better to use subplots. Now, subplots is a good function which been offered by both the libraries. Let's first see how we can do the subplot using SNS. So I'm calling this object called G. I'm saying SNS dot facet grid, and within facet grid, I'm providing my data, which is TF, and column as a column, I'm providing input as occupation. I want to see for each of the occupation how the distribution appears to be. So that's why column is occupation. Now I'm mapping this object and asking Python to do his plot using Seaborn library and use income to generate that distribution for income in each of the occupation. As I execute this cell, okay, as you can see that first plot, it shows that occupation is equal to manager and what's the distribution of income under this population. Second plot is occupation, wherever there is a blue color occupation, what's the distribution of income appears to be, and so on for all occupation level. So it still gives me each individual population, but graphs are much smaller and I still cannot completely see the graph. So I can use something called column wrap as an argument, and column wrap is nothing but for each of the row, how many graphs you want to cover, or in other words, how many columns you want to have. So let's say in each of the row, I wanted to cover, let's say 3 graphs. So I can put column wrap is equal to 3, and as I execute this, you will see that for each of the row, you'll find just 3 graphs, right? So we have since total 8 number of graphs for 8 different occupations. You'll find for each of the occupation, you'll beautifully see the distribution of income. Let's see further the next plot of the day, and that's nothing but our box plot. Box plot is again very crucial to understand distribution of the data. It will give you a minimum, maximum, median, first quartile, third quartile value, kind of a 5-point summary, which you can use and understand more about your data. So let me show you how does this box plot looks like. And for that, I'm just going to import any image. Now in Python, you can import any image with the help of different libraries. But one way I'm going to show you is with the help of IPython library. So we can call IPython. From IPython, and within display, you can call import image, and you can use this image and give a path name to your file. So this is the path of my file. It is in C users HP. Yeah. So now I've given path within my image, and as I execute this, it's going to give me the image. It will import this image in my Jupyter notebook. Now this is a box plot. So you will get details as a minimum, maximum, Q1, that is quartile 1, 25th percentile, Q3, 75th percentile, and median, which is nothing but 50th percentile. And you'll also come to know what are my outliers. So you will also see the outliers visually using your box plot. So box plot, in that sense, it's important to understand the distribution of your data. Let's call plot using SNS, and I'm SNS.boxplot. And within boxplot, I'm providing data is equal to df, and my axis is nothing but, let's understand, travel time. So the column name is travel time. When we execute this, we'll get the distribution or the box plot of travel times. On x-axis, you have travel time, weekly travel time in hours. Okay, there are a couple of outliers when it comes to travel time. So there are a lot of people who are traveling exceptionally high weekly, and their travel time is very high, and they appear as outliers. And you can also see the median travel time is somewhere closer to 35 or so. And on lower side, you do not have any kind of outliers typically. So this is your box plot where you can study about the distribution. Let's customize box plot further. So again, as I said, this is like a horizontal arrangement. You can also see the vertical arrangement. Let's customize our box plot more effectively. So we'll again call plt.figure and set our figure size. So we say that fig size is nothing but 5 unit by 3 unit in height. We also give title to this, and saying that box plot of travel time. We can also give some kind of a padding between the title and the boundary of the chart. Let's say we wanted to give 15 padding, and we also give plt.xlimit. We'll provide this limit starting from -20 to 200 maybe. Similarly, we can put y label as well. Y label, and y label is nothing but travel time. We also set axis style. And axis style, there are many styles. You can go and check out the Seaborn documentation. I'll put the link for Seaborn documentation along with this video. which you can say as white grid, one of the style in Seaborn. And then we are calling Seaborn Boxplot. And here my data is again data frame df, and I'm calling my y because I want a vertical appearance of travel time in Boxplot. So I'm calling y instead of x. And again, I can orient my chart vertically. So I'll provide v, orient is equal to v as a string. Also want color to be changed to maybe more fancy color, say crimson. And for each of those outliers which you see on your screen, this is slightly bigger. So if I wanted to adjust my size of this flyers, can possibly put maybe 2 to make it more smaller. As we do that, we'll see that the graph, the same graph which we see above in blue color is now in crimson color. Also, it is arranged vertically. We also have this title, box plot of travel time, and between the title and the chart, there is some kind of padding. We also have x-axis label and so on. And you can customize your chart based on your requirement. Now, you can compare different groups of the box plot rather than just seeing one variable at a time. So let's try and see this. We'll call it sns.boxplot, and data is equal to df. Here on x-axis, I wanted to understand occupation. So let's take occupation. And I wanted to study for each of the occupation, what is the travel time look like? So on the top box plot, the crimson color, you're just seeing travel time for all population. Now I wanted to see this travel time for each of the occupations. So my y again is my travel time. So name of the column is travel time. And I wanted to provide a beautiful color for my graph. So I'm using palette, and palette, that means what different type of color palette you have. So I'm using this one of the color palette, which is my favorite, Viridish, and let's provide this input and execute it. I'll get this good looking graph, but as you see, that graph is very compressed and narrow. So I can also do something like this. I can call plt.figure and fixed size is equal to, let's say, 10 units by 4 units, and that will do. Now you see that there is an object description also coming along with this. If you don't want this little object description, you can do something like this, plt.show, or you can also call percentage matplotlib inline, just like this, percentage matplotlib inline, and that will also do, right? But for now, we are good with plt.show, and as you do that, you don't find that object description. And this way you can see that different type of distribution in each of the different occupation for travel time. So as you can see that homemaker are traveling, median travel time is slightly higher when it compared to maybe manager or other occupations, so to say. Okay, let's see our third chart of the day, and that's bar chart. Now, bar charts are very important. You might have seen it or even made it in Excel, and it's very intuitive to study bar chart, especially when you wanted to compare 2 or 3 different type of population or even more. So you can call bar chart using sns.countplot. Now countplot is nothing but it will count, so it will appear as kind of a bar. So that's why we call sns.countplot, and data is equal to df. Let's see how many people are there in each of the education category. So in our X, we provide education, and let's execute this. So we know that, okay, high schoolers, number of high schoolers are the maximum, followed by bachelors, followed by masters, and so on. So this way you can generate a count plot, which is very simple by just 1 line of code. Let's see how we can customize this bar plot, and we can compare within this bar plot how we can see the different type of subgroups. So we can do sns.countplot. Again, data is equal to df. On x-axis, I want education, and as a hue, like different type of group which I wanted to study is based on gender. So I wanted to see in masters, how does male and female appears to be in terms of number of people in my data. And again, I am using palette, one of the famous palette, again summer, to see chart in more beautiful color, and providing period is equal to show. As I execute this, as we can see, for each of the different education category, number of females is dominating number of males. So number of females is more across each of the category. And this kind of finer insights you get when you try and study the different type of subgroups. Let's study our next and important plot, which is line plot. And as bar plot, line plot is again very intuitive. When you have a data which is more of a time bound or time dependent data, line plot will help you to understand what has happened over a period of time. So I'm going to call this data of flights and from SNS. So this is a data set available within Seaborn. So you can call sns.load dataset, and the name of the dataset is flights. And this way you can import the ready-made dataset from Seaborn library, and this will be stored under flights. As you see, within the flights data, you can call head to see the top sample of this data. Okay, as you can see that we have year, month, and passengers. So we have year-wise, month-wise number of passengers traveled, and this dataset available within Seaborn. So we are going to use this dataset. Now within this dataset, as we know, it's a time-bound data. So there is a time involved. So this data can be better represented with the help of line chart. So we're calling SNS and Seaborn library, we're calling line plot. Within line plot, my data is flights now. So within flights data, I wanted to have my x-axis is equal to month. I wanted to see month-wise pattern of passengers. So y is nothing but my passengers. And as I execute this cell, it will give me kind of a line plot. On x-axis, I have a month. So for each of the month, what is the total cumulative passenger as traveled? So as I see that from July to September is probably fall months where you find a lot of passengers traveling, and which is very intuitive. But in this graph, you also see there is a blue shaded area. So blue shaded area is nothing but it's kind of a confidence interval, which you see along with the line chart. If you don't want that confidence interval, you can set confidence interval is equal to false there, and you just find a blue line there. So let me just copy this code here and put it here. And the keyword argument here is CI is equal to false. So it's confidence interval. I do not require it. As I do that, that little shaded area is out now, and I just have the plain blue line as a plot there. Okay, you wanted to study different groups within the line plot, like the previous graphs. You can do that, and it's called sns.lineplot again. And within data, calling flights, and calling my x is equal to nothing but my month. And on y-axis, I want again passengers, and hue is year. So I wanted to see year-wise population, and CI, I'm keeping it false. Don't want any confidence interval. As I execute this, I get this graph, which is good. Like for each of the year, I get the population of passengers in each of the month. It's kind of cumbersome, although I can see some seasonality, but it's still not that readable or not user-friendly to read. So let's try and work out maybe different way the graphs, or let's see how we can customize more. So let's call this new data, So we say that new data, and let's select few data points from this flights. So within flights data, I'm saying wherever month is equal to January, use only that data, or maybe February put together. So I'm filtering the data, taking the data of only this 2 months. So when you put this condition within pandas, it will give you filtered data frame from flights. It will take only January and February months data, and it will store into the new data. Now, if you don't know how to filter the data, you should go and watch my videos on pandas data frame. How do you manipulate it? Maybe part 3 and part 4 of this Python series will help you to understand this. I'll put the link right away here. As we include this new data, now our new data, and if I just see the head of it, you'll see that the data will only include the month of January and February across all the years. So now, with the help of this new data, we'll try and customize our different line plots. So we say sns.lineplot again, and here I'm providing my data is equal to new data, and X is year, again, X-axis, and Y is equal to passengers. My hue will be month now, and do not want any kind of confidence interval to be incorporated in my graph for now. When I put style, it will give me 2 different lines for this, and it will differentiate those 2 lines. So when I put markers is equal to true, it's going to give me this square and cross markers. It will also change the style for line style. So for January month, I have continuous line, and for February month, I have a dotted line, and which is of orange color. So all this kind of customization you can do with the help of all this keyword argument in your line plot, and you can make it more beautiful. You can also put title and axis labels, limit of axis, just the way we did it on our previous graph. You can do that as well to make your graph more visually appealing and more readable to the people. Let's see our next plot in today's session. That's scatterplot. Scatterplot, as many of you have seen or might have done it, it's a plot between 2 numerical variables. So scatterplot cannot be done on categorical variable. However, you can use categorical variable to differentiate the observation within the scatterplot. We're going to see this. So scatterplot can be made with the help of, again, Seaborn. You can do sns.scatterplot. We're going to use our old data. So data is equal to DF, which is our insurance data. And from this data, I wanted to study 2 continuous variables. One is income, and on other axis, I wanted to see the home value. And why I wanted to study 2 continuous variables is to see, is there any kind of a linear relationship between these 2 variables. Now, it's very important when you try and build models such as linear regression, try and understand the correlation between 2 variables, and scatterplot will give you kind of visual representation how the relationship between 2 variables affects your model or how strong it is. So let's see this plot. As we execute this, we can see that on x-axis you have income, on y-axis you have a home value, and each of the point is nothing but a record. As income value goes up, your home value goes up too, and that's intuitive. Let's customize this graph again. So let me copy this and let's try and study different groups within this plot. So we can call hue equal to gender. As we do that, we see that for each of these points are now being separated based on gender, whether it's male and female. And by this way, you can study different group within the scatter plot, even if your hue or the different population, you're segregating based on certain categorical variable and not the continuous variable. Okay, so that kind of flexibility you have when you use scatterplot, and you can study different groups within the scatterplots. Okay, I'm stopping here for now, but in our next video, we are going to cover more exciting plot, and that will be the visualization part 2. So stay tuned and do watch our videos. Please like, share and subscribe my channel. Thanks for watching. Bye-bye.